In this video, we are going to look at how we can create numpy arrays. So the most simple way is if you have a list. For example, I have my list before, like this very long list. We can create it using the existing list. So we can have ARI equal to np dot array. So that will create the array. And then we look at type of array. It will tell you it's a numpy.nd array. So that's the fundamental data type of array. And if we look at the dir of the array and see what's inside this, what attributes and functions and methods are inside this, you can see there's quite a lot of stuff here. And we'll look at some of them in future videos. So let's hide this for now. Notice you can also create, say, list2 equals to a list. So you can create not only vectors, if you think about 1D as vectors, but we can also create 2D as matrices, or 3D or 4D high dimensional arrays. So in Torch we call them tensors, so here we call it high dimensional arrays. So we can do this. This will create another array with this shape. So we can actually look at the shape of this. That will return you as 2 rows and 3 columns. Notice, in order to define a matrix, you need to have this complete row and column. So you can't have something like that. So this is fine in a list. So if we separate this out, so this is fine as a list, but then we cannot create a numpy array from this because it's not a complete matrix. Okay, so that's the most straightforward way, is that if you have a list, you can convert it to numpy array using np.array. And the second type of creation is more from like the ground up, create things from scratch. The first thing is similar to range. For example, in built-in Python, we have this range. We can create a range of integers from 0 all the way to the number. So if you just put in one argument, that will assume the start is the 0, but we can actually put in the start as well. Like 2 numbers will assume one is the start, one is the end. And we can also put in the third one, which is the step. So the step just measures what is the interval between all this from the start to the end. So we convert to a list, we can actually see what are the actual numbers. So 1 to 8, we create 1 to 7 because it's not inclusive. Remember, in range or a lot of Python built in, it doesn't include the last element. If we put in 2, that will not include 2, 4, 6 because it will skip them. It will end up as 1 to 3 because it will add 2 each time. 3 to 5, 5 to 7. So which means the default step is actually 1. If we put in 2, they override the default. So in NumPy, there's a similar one called a range. So if we do that, they will create a NumPy array for you directly. And it also does not include the last element, just compatible with the behavior of the native Python. Similarly, we can put in the start and also the step. That will create something like this. So a range is useful if you know what is the interval. In other words, if you have a fixed interval and you know the start and end, it's good to use a range. So pay attention with when we talk about linspace later. So this is good for fixed interval. Okay. Alright, let's look at the next one. Sometimes you just want to create some placeholders or zeros or ones. You can use this zeros or ones. So inside it, you put in the shape. So if we put in one number, that will be an array, 1D array or vector. So if we put in 2, notice I put in as a tuple, so I wrap it up with parentheses and there's a comma inside it. So if we put in 3 and 4, I don't know whether it works, but let's try. Okay, so it doesn't work. It actually takes 4 as the second argument, so this is not correct. So we can also put in like a higher dimensional shape that will give you this. So let's call this ARR zeros equals to this. So this will always be the same as this shape. So the shape we put in will end up as the shape of this Numpy array. Another important attribute is data type. So we can look at how the data are stored. So in this case, it's a flow 64. So when we look at these zeros, you see this dot at the end. Sometimes you just want to create integers. You can put in d type equals to mp dot. So depending on whether you want the sign or not. So you can put it, for example, I just want 0 all the way to 255. I can put unsigned integer 8, that would do. So notice there's no dot after the 0, and actually tells you the d type, which is this. So this is an extra argument you can put in to specify what data type you need. Well, in most cases, if you specify flow 64, or the default one is flow 64, for computation that's perfect because it has the highest precision. But sometimes you don't need that, and you just need a mask, for example. It's better to use integers rather than floating point numbers. The same goes for ones. So you can create the shape, like specific shape filled with 1. And similarly, you can have a d type. Another way to specify the type, or it's most like converting it from one array to another, is to call the method as type. So here you can specify another type. So the difference from like specifying it inside it and use as type is that this one will create the object in one step, but this one will create an object first, and then it will convert it into another object and return that back to you. So you might ask, where does this object go? In this case, it's garbage collector, because as soon as you assign the result of this whole thing to another object, there's no reference pointing to this object, so it will be garbage collected. And then you keep a record of this resultant array. Alright, so this is another way if you want to convert an existing array into this. So essentially this is equivalent to this. But in this case, if we assign it to something, it won't be garbage collected because it has a reference pointing to it. Another useful function is that if we recall the previous array, which is array 2. So array 2 is an array with 2 rows and 3 columns. And say if we want to create a mask, like define a mask over that, we want to first initiate all 0 as the mask, we can do np.array, sorry, np.zeros like of this. So it would look at what's the shape and data type of this, and then create a 0 array using that. So that will create all zeros. Okay, the next one is namespace. So in namespace, we can specify the start, the end, and also how many points are there. So in this case, we start with 0 and ends at 1, and we want 21 points. So this one is n inclusive by default. So if we do this, it will start with 0 and with 1. And if we count how many numbers are there, there will be 21. We can actually assess that using the shape. They will tell you it's 21. Okay, so compare with this one with the A range we talked about earlier. So the A range is if you know a fixed size, because this is similar to the range function in Python. You can specify the step and we'll move to the next number using this step. So if you know the fixed interval, you want the interval to be fixed, use this one. And for namespace, because 21 is the final output that we will have, so this is if you want to get a fixed output shape, you will use this. So depending on what you need, you can choose these two functions. So the last one is sometimes you want to get a placeholder. You don't really care what's the number inside it. Of course, you can use something like the zeros or the ones, but sometimes you want more realistic, just some random numbers inside it. So Numpy has the random sub package inside it. And you can actually look at this package. It has quite a lot of functions under it. And if we just get some random number between 0 and 1, we can actually put in something like this. So we create a random array that has 3 rows and 4 columns. So notice here we don't need to wrap it as a tuple. So if we wrap it as a tuple, it will actually cause an error. So in this case, it requires the argument to be something like this, right? So how to know about this is actually just look at the documentation of this. And you can see this has a star at the beginning. This is about when you define a function, you can specify it just accepts arbitrary number of inputs. So that's what exactly we can see here. They can accept arbitrary length of the input. So if we, for example, look at 0, so you see this one has the shape as the first argument. So the shape is just one argument. So you need to, if you have different shape, you need to wrap it out as one thing here. So that's why you need to put in as a tuple. So there are more methods to create Numpy arrays, but with this you are good to go, because this gives you enough method to create Numpy arrays for your normal tasks.